Hello everyone, myself Sanskruti Thorat, and these are my team members Aditya Khairnar and Jagruti Suryawanshi. We all are from MET Institute of Engineering Nashik, Department of Electronics and Telecommunication Engineering. So we are here to present our project which is Car Black Box, which we have developed during internship at EMERTXE Bangalore. So let's get started. These are the contents of PPT. Topics learned during internship, introduction, purpose, requirement, what are embedded systems, microcontroller, microprocessor, how to choose embedded system, PIC16F877A, project implementation on hardware and software, then application and conclusion. So the topics which we have learned in the embedded C was Introduction to C and data types, conditional construct and operations, operators and array, pointers and functions, recursion, constant qualifiers and strings, storage classes and preprocessors. So let me give a brief introduction about the car black box. The concept of black box is mainly heard by us in the case of airplanes, but black box is used to analyze the root cause of the issue. Then the black box is also known as event data recorder, that is EDR, or accident data recorder, that is ADR. The black box can be installed in some automobiles to record various events. A car black box is a device which is installed in your vehicle, in your car, which will monitor few events, which will monitor your driving, like it will record the event like accidents, then it will record the speed, mileage, and other parameters. Few car black box recorders also records the locations. It is also known as event data recorder. These events, which are electronically sensed, can often proactively detect any issue in vehicle, for example engine fault, or monitor the flight, that is driving over speeding, etc., thereby doing proactive maintenance of automobile vehicle. The basic purpose of car black box is to log all critical events like the gear shift with current speed, the engine temperature, fuel consumption per trip, trip distance, etc. A car black box focuses mainly on enhancing safety standards of driven vehicle by monitoring vehicle performance and driving behavior. Whatever events get recorded by this box we can viewed by law enforcement agency in any case of any issues. The system should allow the password-based access to the transport manager to view or download the log to PC if required. So what does the embedded system mean? The embedded system is a combination of hardware and software which is intended to do a specific task. A general purpose system, that is GPS, is used to perform large number of tasks, whereas the embedded system, that is ES, is used to perform a specific task. There are basically four types of embedded systems. First one is standalone system, second one is real-time system, third is networked system, and fourth is mobile system. So let's see one by one. First one is standalone embedded system. Standalone embedded system does not require a host computer to function. They can produce output independently. The examples are digital cameras, digital wristwatch, MP3 players, applications such as refrigerators, washing machine, microwave, then calculators, temperature measurement systems, etc. The second one is real-time embedded system. The real-time embedded system must provide the result or output promptly. The priority is assigned to the output generation speed, as real-time embedded systems are often used in mission-critical sectors such as defense and aerospace. For example, the real-time embedded system includes aircraft controls, land vehicle and flight computers that process and transmit sensor-acquired data, then missiles defense system control, autonomous and semi-autonomous vehicle controls. The third one is network embedded system. The network or network embedded system really on wire or wireless communication with web server for output generation. For examples, it includes the home and office security system, then ATM machines, then point of sale systems. The fourth one is mobile embedded system. The mobile embedded system refers specifically to the small portable embedded systems such as cell phones, laptops, and calculators. There is some overlap between the constituents of the constituent a mobile embedded system and standalone embedded system. It should be noticed that all mobile embedded systems are standalone embedded systems, but not all standalone embedded systems are mobile embedded systems. So, basically, what is the microcontroller and microprocessor? So, in a microcontroller, all the components are on the single chip, while in the microprocessors, all the components are embedded separately. Microcontrollers are basically less physical than microprocessor. Then the microcontroller has a very less design complexity, but the microcontroller is more complex designed. So these are basically some microcontrollers which we commonly used, that is PIC 18F877A, 8051, Arduino, Atmega 328P, and these are the microprocessors which we commonly use, such as NVIDIA, Intel, etc. So how to choose the embedded system? Basically, there are some criteria which is to be followed during the selection of embedded systems, such as it should consume a low power, then it should be cost efficient so that everyone can be it can be afforded to everyone. Then efficient use of processing power, then reliability and efficient use of memory. This is the actual architecture of PIC 16F877, a microcontroller, which has the output peripherals like GPIO, I2C or real-time clock, then LM35 temperature sensors, ADC, RS232, LEDs, buzzer, digital keypad, SSDs, matrix keypad, and CLCDs. Some of the peripherals perform the two-way communications, while some of them performs only one-way communication. Then the basic requirement for this project is a software which is MPLAB XID version 6.00, then MPLAB XC8 compiler, PiximLab which should have the PIC16F877A microcontroller and 16 by 2 LCD, and the important thing is we should have the knowledge of embedded C.
I will be explaining you about the peripherals used in the car black box system project. So firstly we have used LCD display 16 by 2. So mainly we are going to show output display like main menus, actual timing, and like car speed and all in the digit form, display form, sorry. So after that we have used 6 tactile switches, which is also called as debounce buttons. It works as a spring mechanism, like a spring mechanism, which is used to connect the electrical circuit and send ones and zeros signals to the microcontroller in the project. So after that we have used potentiometer. It is it's also called as the variable resistors, a variable resistance device in which we can vary any resistance value we want or a user want. So why we have used the potentiometer is because we are going to vary the speed of the vehicle, which I will be showing in you in the following video. So after that, we have used EEPROM memory. Why EEPROM memory? Because it is electronically erasable memory. So I will be explaining you in detail, don't worry. So what it mainly does is that it simply erases the old memory if the user wants, and we can feed the new memory a new data again without removing any chip or without any software. So the main heart of the project is microcontroller. So we have used PIC 16F877A. Sorry, I have not. We forgot to mention here A, like a human mistake. Sorry, but we have used this is PIC 16F877A microcontroller. So it is the main heart of the project. This microcontroller belongs to the PIC family. So this is also common, by the way. Okay, let's move forward. After that, we have used a real-time clock circuit. So why we have used it? So we will be implementing project in real-time world, real life. So it must show the correct value, na? Like uh, perfect digits, perfect clock means in seconds, minutes, and months, date, everything. It works normally as like our clock, normal clock, and they are mostly accurate. So we will be using this real-time clock circuit in our project just to show that it is working in real time as in the dashboard, car dashboard. Okay, so let's move forward.
So, in this project, we have used many concepts like event capture. Then, required event have to be captured and stored in the memory. Every event should have a format as event signature, event time, speed at the event. The event should be captured real time, no matter in which mode you are in. View log should display all the events captured with the log index starting from 0 like event number, event signature, event time, speed at the event. The up and down key will be used to scroll the entity. The rollover on reaching the max log entry. The system should be live. Capture events occur even while viewing the log. A long press of up key should take you back to the main menu. Default screen. When the system is in operation mode, it would act like a dashboard which would show the current time, speed of vehicle and latest occurred event. Login screen. On the press of up or down keys, the system should prompt for password. The password would be the combination of 4 presses. Each press should be denoted by a star. Every wrong entity read prompt for the password maximum for 3 times for every 15 minutes. Incomplete key press pause for 3 seconds would lead to default screen. Set time. Set time should show the current time. The seconds field should blink indicating the field to be changed. The up key should be used to increment the time rollover on reaching max. The down key will be used to choose the field. A long press of up key should take you back to the main menu. Main menu. The main menu should contain two options, that is view log and set time. The up down key are used to navigate. The long press of up key should enter the selected menu. The long press of down key should log out. The ideal screen for more than 5 seconds should log out. So here are some basic information about which hardware we have used. First one is display 16 by 2 LCD. A 16 by 2 LCD is very basic module and is very commonly used in various devices and circuits. A 16 by 2 LCD means it can display 16 characters per line and there are two such lines. Second one is tactile switches. Tactile switches are an electromechanical device which is used to start or stop current flow along the circuit. A tactile switch allows electricity to flow in electrical circuit by manually pressing the operating section. The switch is used to supply input signal to actuate a device or equipment. Third one is potentiometer. A potentiometer is a three-terminal resistor with a sliding or rotating contact that forms an adjustable voltage divider. A potentiometer has two terminals of the input source fixed to the end of resistor. To adjust the output voltage, the sliding contact gets moved along the resistor on the output side. Fourth one is EEPROM. EEPROM, that is the electrical erasable programmable read-only memory, is a user-modified read-only memory, that is ROM, that allows the user to erase and reprogram stored data repeatedly in application. In a contrast to EEPROM chips, EEPROM memories does not need to be removed from the computer in order to modify the data. Fifth one is the very important component, that is PIC16F877A. PIC16F877A is 40-pin PIC microcontroller designed using the RISC architecture, which is manufactured by Microchip and it is used in many of the embedded projects. It has a 5 ports starting from the port A to port E. It has three timers, two of them which are 8 bits and one is 16-bit timer. The sixth one is real-time clock. Real-time clock is a computer clock, usually in the form of integrated circuit, that is solely built for keeping the time. Naturally, it counts hours, minutes, seconds, months, days, and even years. RTC can be found running in personal computers, embedded systems, and servers, and are present in electronic devices that may require accurate timekeeping. So basically, the black box can be applications. So the black box can be installed vehicles to record various events. These events, which are electronically sensed, can often proactively detect any issue in the vehicle like engine fault or monitor the fleet overspeeding, etc. It can be also very useful when there is some criminal issue going on accident case of the vehicle. So now my friend Aditya Khairnar will explain you about the software and hardware simulation of this project.
You will be interested. So this is MPLAB XID, this software. So what we have done is, this is the code written by us. So if you first see it, so what this code does is that we have programmed LCD display, all tactile buttons, all one potentiometer, and real time, and to show the real time. We have programmed the main to show the main menus, password system. Of course, let's go forward. So I will be building this project. Okay, sorry, one warning, John. Okay, the build is successful. I will do it again. Okay, the build is successful. Now, what it does, that it will create a hex file. So let's move forward to actual hardware part. It means in simulation. Okay, so I have already loaded the hex file here. Okay, so this is the fixing lab software. So we have used this is the board, Peak Genius board, and we have used the Peak 16F877A microcontroller. See, this is the microcontroller. These are the LEDs. So we are not going to use the LEDs. We can on it on off here also, but we don't need it. Okay, so let's come to the main part. This is LCD display 16 into 2. See, you can see here. So we have used here 20 megahertz clock speed. So that 6 tactile switches which I had described earlier are this RB2, RB1, RB0, RB3, RB4 and RB5. So what does this RB2? This is the display. Uh, this shows the real lifetime. This is the engine on off. This is the speed. Okay, let's move forward. So this is P1AN0 is the potentiometer. Okay, let's change the speed by varying the potentiometer. Now just observe here SP. SP means speed and below is the digit, speed digit. Okay, see carefully. See, it went to 99. Okay, so what this RB2 does is reduces the gear and this RB1 increases the gear. See, this is neutral. Is the neutral gear. If I press this RB1 again, it goes to reverse gear. If I press it again, it goes to gear 1, gear 2, gear 3 and gear 4. And what this RB2 does is reduces the gear. Okay, so let's do the collision. See, finally the situation is like assume the situation that a vehicle is collided. So we want to check the logs, what that driver had done earlier, or what are the mistakes of him. So what we are going to do is RB3, pressing RB3 for the getting the password for means to log in to see logs. So what I am going to do here is press the RB3 and if I wait for 5 seconds it will return to if the password is not typed within 5 seconds, after that it will return to main menu. See, 1 2 3 4 and 5. You see that? So let's move forward. I am going to type the password. So in my case it is 2424 RB4 and RB3. So here you can see view lock, clear lock, and the third one is reset password. This RB4 is used to change the change the menu, and RB5 is used to select the menu. So first of all we will see view lock. Okay, so this is the logs. Here we can store up to 10 logs. So this is hashtag 0 since it's 1. Okay, so as you have seen, if you enter the wrong password 3 times, the user will get blocked for 60 seconds. So I'm going to show how to clear all the locks. So 1 minute. Let's enter the correct password. Now here, second option is clear lock. So to select it, we will press RB5. So guys, you can see logs cleared successfully. It's clearly visible. Now one more interesting thing. Let's change the password. Okay. So the menu has come. New menu has come. Please enter password. So we can put any 4-digit password as per our need. So in my case, I will press RB3 4 times. You can keep any one of them. So again, it accepted the password and it told to re-enter new password. So I'm going to press it again. And finally, password change successfully. Okay. So this was our project on car black box system. So thank you.
So let's see the application of this project. The car black box can be installed vehicle to record various events. These events, which are electronically sensed, can often proactively detect any issue in the vehicle like engine fault or monitor the fleet overspeeding, etc. It can be also very useful when there is some criminal issue going on accident case of vehicle. So now my friend Aditya Khairnar will explain you about the software and hardware implementation of this project. Thank you Aditya. Now we will conclude this video. Hence, in the EMERTXE internship of embedded system, which was conducted for nearly 4 weeks, we have studied various basic concepts like embedded C programmings. In that, we have studied the loops, operations, functions, strings, array, pointers, storage classes, etc. Then the peripheral interfacing of PIC16F877A with LED, digital keypad, timer, potentiometer, CLCD, tactile switch, project implementation, which was a simulation, both hardware and software, and many more concepts. So thank you so much EMERTXE team for giving us this opportunity to do internship and with such a great project. We have learned a lot of things during this internship about embedded system. Thank you so much.
Thank you, EMERTXE team. Thanks a lot for giving this awesome opportunity to do internship with you with this awesome project, car black box system. It was really interesting to work with it, and we also learned many new things like embedded C program, peripheral interfaces, and lot things. So thank you everyone.